record. All right, recording for whoever else wants to watch this afterwards. So chapter 1 was all pretty basic, just the introductory stuff, as you remember. One of the main things that it touches on is the differentiation between the conceptual definition and the operational definitions. And so conceptual definitions are basically they describe what are the values that you're looking at. So whether it's you're looking at people, nations, voter turnout, whatever it is. And so it says here that it describes measurable properties. It specifies the units of analysis, and then it should make the intended meaning clear. Now, when you compare that to the operational, which describes the instrument being used to measure that concept. So conceptual is what you're measuring, and then operational is how you're going to measure it. So it's basically the questions to be considered. And, one of the big examples was with religiosity. That is the conceptual definition, and the way that you are going to see that, the way that you're going to measure that is by the number of times a person goes to church in 1 year. And so same thing, example with the way you're going to measure war is by 1,000 battle-related deaths. So there are other things that you can read through here. Oh yeah, and then so the other big thing is when you're coming up with what you're going to be measuring, you need to figure out what level of analysis you're doing, whether it's the individual or whether it's the aggregate level. So remember, individual is at the lowest thing, just per person, this is what each individual person voted or how they felt about this or whatever. And then the aggregate level is where you take a whole group of individuals, say from one region, and you combine what they felt to, or how they voted, or whatever the measurement is, you combine that together to kind of talk about the whole area. And so with that, you need to be aware of the ecological fallacy. We got a couple more people joining, a little late. So then we have the ecological fallacy, which is when you can make incorrect conclusions about the individuals based on the aggregate data. And so are there any questions about this first part?
Just to be clear, aggregate is a whole group. Individual is really literally just one person, one thing.
Exactly.
Right? Okay. And then what about the ecological fallacy? I'm sorry, I zoned out.
So it's the ecological fallacy is when you're making conclusions about individuals based on aggregate level data. So maybe an example of this would be, say for California as a whole votes really Democrat. So you're pretty sure that, people out in the more rural areas of California also vote Democrat, when really just in most places in the country, people vote more conservative or Republican. And so you're taking that information about the aggregate level where it's as a whole, California is generally more liberal and democratic. And then when you apply it to one section of people from California, that can be incorrect.
Okay.
And for any of the people who just joined in the last couple minutes, If you want to put your email in the chat, I will send out the study guide that I wrote up to you, and that way you can kind of follow along.
Thank you.
Were there any other questions about the conceptual definitions, units of analysis, or operational definitions?
I see in my notes that in operational definitions, we use a feeling thermometer. Is there an example of what we use for conceptual definitions?
Those are going to be like the states, people, you know, just like it's whatever you are studying.
Okay, so there's no like specific kind of way to measure a conceptual definition.
Correct. Yeah, because that your conceptual definition is just what you're studying.
Okay. And the operational is how you're studying it.
Exactly.
Got it.
Everyone else good? No one else needs the study guide? All right, so moving on to measurement errors. Obviously a measurement error is you have intended and unintended characteristics that you want to measure. And so the unintended characteristics are what we're calling measurement errors. And then there's two main types of errors. One is the systemic measurement error, which basically means you did not design your experiment correctly. It is not measuring what it is supposed to be. It's kind of like the example from our exercises where the guy's trying to get the weight of his dog. So he picks up his dog and he steps on the scale with his dog in his hand. Well, he's trying to get the measurement of his dog's weight. Instead, he got the measurement of their combined weight. And so it's one of the big things is that it's going to be consistent and chronic distortion. So whereas random measurement errors can kind of just be chaotic and sporadic and do different things, like no matter how many times that guy steps onto the scale with his dog, he is always going to, you know, say he weighs 130 pounds. The weight is always going to be 130 pounds over what his dog weighs. And so that's the big thing with systemic measurement error, is that it's always consistent. And it's also often called measurement bias, just because like no matter what, it's always going to be reading the wrong way. And so it's going to be very reliable, where you're always going to get the same type of answer, but it's not valid because you're not getting a true measurement. Then, like I said, random measurement error. These are haphazard. They're completely can go off in different areas, and they just kind of produce inconsistency in your readings. And so usually one of the best ways to like get that off is by taking a larger sample of readings. And so that you can, when there's just like random ones that are like way off to the side, you're like, oh, something's wrong with that one. So just kind of ignore that little guy over there. So moving on to the unintended characteristics. In one of the examples, they talked about how, when you're trying to study math, but then you made all the math word problems, the unintended characteristics that you're doing is you're looking at people's verbal ability and you're looking at their test anxiety, not just like what they need. And so those are those durable ones, or it's considered a durable, where it's basically, once again, you set up the assignment the wrong way, or you set up the experiment the wrong way. It's not fully testing what it should be. And then the temporary ones are kind of more the randoms where, you know, just different random fluke things, person's having a bad day, you know, a fire alarm's going off in the next building over, whatever it may be. And so those just make it a little bit more difficult. So then we move on to, is there any questions about these measurement errors and unintended characteristics?
Go ahead. Oh, is there anyone else? I was gonna ask, to clarify, so the standing on the weight would be the unintended characteristic, and would it be durable?
So that is actually going to be a measurement error, not a unintended characteristic. Because, so kind of the difference here is the measurement errors are when you're like not measuring the exact thing, like you're having things that throw off your measurements. So like weight is a good example of, you know, the dog weighs 40 pounds. So when your measurement should be around 40 pounds, but when you step on there, you're getting all the way up to 170 or 185 because of your 140, whatever pounds. And so it's bringing the measurement off. Whereas unintended characteristics are like, so you're trying to measure your dog's weight, but for, well, I mean, okay, that's, the dog one's a really bad example. So in this, you're trying to test math ability, but the unintended characteristic that is also being tested or is having effect on it is someone's verbal ability. And so, and that was because of an issue with the way the experiment was designed. Instead of like the math abilities problem being answer being skewed or whatnot, it's you're actually, they're like, they have to overcome the verbal ability before they can get to testing their math ability.
I see. So like it's like a whole different category. Yeah.
Right.
Okay. Okay. Thank you.
So what the measurement errors are like, instead of measuring one apple, you're measuring 5 apples. The unintended characteristics is you're measuring apples and oranges.
Thank you so much.
Okay. Any other questions before we move on? Right. So next we're going to go on to reliability and validity. So same thing as we've like gone through before. Reliability is repeatability, is that you're getting the similar answers every single time. Your measurements are all right around each other. Whereas validity is that you're getting actually proper, correct answers. So like with the dog thing, you know, it might be reliable because you get 180 pounds every single time that you weigh you and the dog, but it's not valid. And so we have the book definitions there that you can read. But so when you're evaluating reliability, when you're trying to see how, you know, is my experiment reliable? Is it always going to get the same things? And so the main thing is just the test retest method, where, you know, you run it once, you run it again and again, and you can just see like how close you're getting. The alternative form method, down in here. Well, I don't think that's, oh yeah, so the alternative form is where the investigator administers 2 different but equivalent versions of the instrument. It removes the weakness from the test retest method of participants remembering their answers. So this would be, so like say you had 20 questions And so the test retest, you have people answer the same 20 questions. The alternative form method, you would have them at one point in time answer these 10, then the next time answer those 10. So they're not answering the same things. And then the drawbacks over time consistency is just when people do the same thing over and over again, they just kind of remember what they were doing. And then always that there can be problems with with people when they know they're being measured, that they can kind of skew their answers, so you're not getting true validity or a true measurement. So, and then there was your face validity, which is where like basically it's just looking at the experiment, it is proper, and it is going to give. Give me a second. For some reason, my Zoom is telling me I only have 10 minutes left for this meeting. All right. Well, I will probably have, when this Zoom goes out, I'll start another one and we'll continue.
I grasp the concept of reliability, but I'm still trying to understand like what makes it valid. Like, can you clarify that a little bit more?
Valid is that you're getting like a true measurement.
So it doesn't mean that it's consistent and you get the same number. It just means that you're actually getting the right measurement because you're doing it right or something.
Correct.
Okay.
So with that, it's kind of a weird thing because it kind of seems like, how can something not be, or like, so if you did multiple measurements and say 2 out of 5 we're getting a true measurement and then the other ones are kind of outliers, that is a valid experiment, but it's not reliable. And so really what that means is that you need to rework your experiment where you make it more reliable.
Okay.
So, because yeah, it kind of sounds weird that something can get the true measurement, but it can't be reliable. But the main thing is that you just have to get it to where it is, your experiment is reliable and there is validity. And then the construct, so we have face validity, which comes from your experiment. And then there's also construct validity, which is like that there is the expected empirical relationships between what is being measured, the independent and the dependent variable. And that's where you get your construct validity. So the main thing with science versus pseudoscience is just that a theory is truly scientific if it is falsifiable, if it can be proven untrue. That's probably all you really need to remember from that. Anything other than that is a pseudoscience or just personal. And that pretty much, that's done with chapter 1. Did you guys have any questions before we go to chapter 2? All right, so I'm going to go ahead and just end this meeting right now, and then I'll shoot another text out to the group, and we'll do another meeting, and we'll probably just have to do it for each chapter. But then also I can upload these videos to YouTube like chapter by chapter.
Okay.
All righty, I will talk to you guys in a minute.